Right, here we're looking at section 8.4, and our learning targets for the section are use the triangle proportionality theorem and its converse, and then we're going to use some other proportionality theorems. And we're still looking at similar triangles and different pieces of the triangles that we know. So here are these theorems that we're talking about. The first one is the triangle proportionality theorem. So this tells me that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So we're looking at these two sides. QS is parallel to TU, and I know that because of these two little triangles. That tells me they are parallel. So if I know that these two lines are parallel, then I know that the proportion from RT to Q to TQ is the same as the other side, so RU to US. So I know that those proportions are equal. So looking at the converse, I know that if this line divides the triangle proportionally, so if I know the proportions of RT and TQ and the proportion of RU and US, if we know those proportions and they're equal, then I know that the lines are parallel. So that's my converse. So we're really looking at lines parallel to one side of the triangle. It doesn't matter which side. So let's look at our first example. So in the diagram, QS is parallel to UT, and RS equals 4, ST equals 6, and QU equals 9. What is the length of RQ? So again, always draw our picture first, which has already been done for us here. Now I can set up my proportions. So I know using my triangle proportionality theorem that this piece, so my RS over ST is equal to RQ over QU. So the top part over the bottom part is equal to the top part over the bottom part. So now that I've written out that proportion, I substitute the things that I know, the side lengths that I know, and I go ahead and I cross multiply and I simplify, and I find out that RQ is 6 units long. So I can think back, does this mathematically make sense? Well, I see on this RT side of my triangle that the top part is a little bit more than half, but it's not quite the entire length of ST. So I see over here that this top part we found is a little more than half, but not this entire length. So I would say that I'm mathematically in a good spot. So I always want to go back and just double check, does my answer even make sense before I give it as my final solution? So here is your first monitoring progress. Try this, see how you do. So now here's our next example. So on the shoe rack shown, BA equals 33 centimeters. And I'm going to go ahead and label these, right? Because we always want to draw our picture and then label what we have. So BA is 33 centimeters. CB is 27 centimeters. CD is 44 centimeters. And DE is 25 centimeters. Explain why the shelf is not parallel to the floor. Well, so going back to my converse, I know that if these two, if my proportions are the same, then it is parallel. So let's first set up our proportions. So we want to simplify my ratio. So I look at CD over DE. So I'm going to look at this right side first. So I've got 44 over 25. So then I'm looking at the left side. So I've got the 27 over 33, and that can simplify to 9 over 11. So since these fractions are not the same thing, we know that the BD is not parallel to the ground, which was AE. So the shelf is not parallel. If these two ratios were the same, then I would know that the shelf is parallel. So look at this one. Tell me if those lines are parallel or not. So here's our next theorem that we're going to look at. So our second learning target was using other theorems with parallel lines. So if I have 3 parallel lines and I have 2 transversals, you see here my 2 transversals are line L and line M, then these 3 parallel lines divide the transversals proportionally. So really what that means is the proportion from UW over WY is the same thing as VX over XZ. So I'm really looking at different pieces. So this kind of is going to be the top piece on both of them, and then this is going to be the bottom piece on both of them. But I also want to keep in mind that this is going to kind of be my red line, right? And it's going to have my 2 different parts, and then this can be like my purple line. So I want to organize them. All of my red line stuff is first, and all of my purple line stuff is second. All of the green is on top, and all of the blue is on the bottom. So it's just one way I can organize my ratios that I'm looking at. So here's our example. So in this diagram, angle 1, angle 2, and angle 3 are all congruent, which is also labeled over here. GF is 120 yards, DE is 150 yards, and CD is 300 yards. So find the distance HF. So this entire length between Main Street and South Main Street. So I'm asked to find this entire distance. So the first thing I do is I see that my corresponding angles are congruent, and I know that the fact that these angles are congruent tells me that I have parallel lines. So I know I can write out my proportions now. So I'm going to use my 3 parallel lines theorem to set up my proportion. So I know that HG, down here, over GF is the same thing or is equal to CD over DE. So I set that up, I substitute the things that I know, and I solve and simplify. So I was asked not just for this length GH. That's one thing I need to be really careful is in my directions, I'm asked to find the entire distance HF. So here I just found what HG was. So now I'm going to add the other piece in this 120 that I was already told to find the entire length, right? That's my segment addition postulate. So the distance between Main Street and South Main Street is 360 yards. So that's really what I always am going to do. I'm going to set up my proportions, substitute what I know, and then simplify. Then I always go back and check what was I actually asked to find and make sure we're finding the right thing. So here's our next theorem. So this is our triangle angle bisector theorem. So if a ray, in this case CD, bisects an angle of a triangle, and remember bisect means cut in half, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So what we're really looking at is this side length AD over DB is proportional or is equal to this whole leg divided by this whole leg. And this is only true if this ray or if this line segment cuts this angle in half, if it bisects it. So let's look at an example. So in this diagram, angle QPR is congruent to RPS. Also, it's already drawn, so I don't have to draw this out. Use the given side lengths to find the length of RS, which is given by S. So I know that it's an angle bisector, so since I know that, I can use my triangle angle bisector theorem. So I'm going to label RS as X. So then I know that RQ, this little piece that I also need to know, is going to be 15 minus X. Sometimes I'm told some information that I then have to analyze and figure out before I can actually start solving my problem. So we know with our angle bisector theorem, our triangle angle bisector theorem, I need to know this length just from the angle bisector to the opposite side, which I wasn't given that, so I have to find it. So if I know the entire length of this triangle is 15, and RS, what we're looking for is X, I know that this part left over is going to be 15 minus X. That's how I get what RQ is. So now I set up my proportions. RQ over RS equals PQ over PS. Then I substitute the things that I know. Then I cross multiply. So 7x equals 13 times the quantity, 15 minus x. So then I solve for x. So I would add 13x to both sides and then divide to solve for my x. Then I look back and say, what was I actually asked to find? I was asked to find x on this one. I was asked to find the length of RS, which I labeled as x. So I don't have to do anything else. I know that I've found what I was asked to look for. So here are your next couple monitoring progress. I want you to try a couple of these. Try one from each part. Try one of these dealing with our parallel lines, and try one that is looking at the triangle angle bisectors. See how you do with those ones. So now we're going to look back at our learning targets. So our first learning target was to use triangle proportionality theorem and its converse, and that's really where we're dealing with parallel lines inside my triangle and the proportions that it creates. Then the second learning target was to use other proportionality theorems, and that's where we looked at the triangle angle bisector and we looked at the three parallel lines. So first we looked at the three parallel lines and the proportions that it makes, and then our triangle angle bisectors and the proportion that it makes. So the biggest thing to remember is that we have to write out our proportions, and we want to keep those organized, and then we can substitute what we know and solve for any missing things. So now I want you to go through and work on your homework for 8.4.